guys, welcome to my channel. Please make sure you subscribe my channel or hit the subscribe button under there for me. In today's tutorial, we are going to look at Introduction to Programming in Basic 8. Our content standard will be taken from Basic 8, Strand 4, Substrand 1, indicate content standard 1, which is show an understanding of the concept of programming. And in our today's performance indicator, we are going to describe the basic concepts in programming, such as constants, variables, expressions, statements, and or instructions, logic and arithmetic operators, operator precedence. Understanding basic concepts of programming. Almost all programs consist of some basic building blocks assembled different ways to achieve a particular goal. So, what is programming? Programming is creating sets of instructions to perform a specific task. Let's take a look at some of the basic concepts we will be covering in today's lesson. 1. Operator precedence. 2. Statements or instructions. 3. Logic and arithmetic operators. 4. Expression. 5. Variables. And 6. Constants. Operator precedence. What is operator precedence? Before I tell you the meaning, let's look at the difference between operator or what is operator and what is precedence. In our elementary mathematics, we are familiar with the basic operators such as addition, subtraction, multiplication, and division. Those are the operators we are familiar with. Now, what is the precedence? Precedence is just to tell us that that particular operator is having a higher rank than the others. So the higher the operator, it says, or it is its precedence. Okay, so now, what is operator precedence? In mathematics and computer science, the order of operation is a collection of rules that reflects conventions about which operation to perform first in order to evaluate a given mathematics expression. Hence, operator precedence. These rules are formalized with a ranking of the operators. The rank of an operator is called its precedence, and an operator with a higher precedence is performed before operation with lower precedence. Calculators generally perform operations with the same precedence from left to right, but some programming languages and calculators adopt different conventions. All this is to tell us that some operators have higher ranks, and therefore they must be treated first before other operators. Precedence of operators. Precedence of operators come into picture when in an expression we need to decide which operator will be evaluated first. Example, This is our expression. 2 plus 3 multiplying 5. My question is, which of these operators have the higher precedence? Is it addition or multiplication? Remember, precedence of multiplication is greater than addition. In so doing, we are going to tackle multiplication first before we tackle addition. So, in our multiplication, it's going to look like this. 2 plus into bracket 3 multiplying 5. It means that multiplication supersedes addition. So we have to do multiplication first before we go on what? Addition. So addition will also look like this. Associativity of operators. Associativity of operators come into picture when precedence of operators are same and we need to decide which operator will be evaluated first. So in this situation, we are not dealing with precedence of operators, but rather we are dealing with associativity. Let's take an example. This is our expression. 10 divided by 2 multiplied by 5. So we have two operators here. And these two operators have the same precedence. Okay? They are of the same precedence. They are equal. Their ranks are equal. So which one do we treat first? So this is where associativity comes in. Now, let's look at this. When we decide to do with division first, this is how it is going to look like. 10 divided by 2 multiplying 5. Or we decide to do multiplication first. 10 divided, bracket open, 2 multiplying 5, bracket close. Now, remember that in associativity can either be left to right or right to left. What do we mean by left to right or right to left? Where the bracket begins determines where the left begins or where the right is located. Where the left is located and where the right is located. So left to right begins from here because the bracket starts from what? Our left hand side. So it is from left to right. Then in this expression, the bracket is on our right side. So it is from right to what? Left. Okay. So this expression here is from left to right. And this expression here is from right to left. Now, which of these two expressions is correct? To judge that, let's look at their answers to judge. So, in our first expression, which indicates left to right association or associativity, states that bracket open 10 divided by 2, bracket close, multiplying 5 will give us what? 25, of course. Then let's come to the second expression. 10 divide, bracket open, 2 multiplying 5, bracket close, will give us 1. So, colleagues, which one is the correct one? I guess it's the 25. I will tell you one thing. Division will be performed first and then multiplication, because these two operators are having the same precedence, and associativity is actually from the left to right and not from right to left. Therefore, bracket open, 10 divided by 2 bracket close multiplying 5, which is equal to 25, is the correct one. And 10 divide bracket open 2 multiplying 5 bracket close equal to 1 is the wrong one. This is how computers work. Computers tends to run through precedence. Then when they go through the precedence and the precedence are the same, then they go in to look for associativity. So the associativity will tell them which operator to be performed first before the other. Now let's consider the precedence and associativity table. In this particular table, you will find out different kinds of operators mentioned. Apart from that, the associativity are also mentioned. The topmost, the topmost of operators are having the highest precedence. So the topmost here operators are having the highest precedence among all the operators in the table, and the bottommost is having the least precedence. Okay, then as it graduates down here, then they are losing their precedence until it comes to the last one. Okay, all right. So is their associativity. So the topmost operators have the associativity from left to right. Please, associativity comes to play or comes in the picture when the operators are having the same precedence. Then associativity comes in. So you just have to use the associativity to determine which one will you do first. Okay, so down here we have the unary operators. Okay, and this one is the logic not operator. Then we have the bitwise negator. Then we have positive increment. But here we have the plus and the minus. This may confuse you or might confuse you. But these ones are just like a symbol, like plus 35 and minus 35. Okay, they are just symbol that gives meaning to a word or a number. Okay, all right. So these are the unary uh, symbol or operators. Okay, and they have the associativity from right to left. Then we have the multiplicative operators. So the multiplicative operators are here. We have the multiplication sign, we have the division sign, and we have the modulus. Okay, we have the modulus. So their associativity is from left to right. Okay, so when you find both of these operators in one expression, okay, then you have to go in for the associativity, the one that you need to what do first, okay, solve first. Then we have addictive. So the normal this in addition and minus is there, okay. So their their associativity also ranges from left to right. So this is the summary of the precedence and associativity table for our operators. We will be talking much about this in our subsequent tutorials that are coming, okay, so that you'll be familiar with this. And all these operators are used in a computer programming or algorithm, in writing an algorithm, and even in structure, okay, the algorithm structure. All these operators are used in the structure or in writing a program or algorithm. Let's take a look at our second basic concept in programming. And our second concept is statements or instructions. So, what is statement or instructions in programming? A statement or instruction is a group of expressions that you designed to carry out a task or an action. Any group of expression that you design to carry out a simple task or a specific task or an action is deemed to be as a statement or instruction. A statement or instruction is a command that the programmer gives to the computer. In fact, everything you write in a language is a statement. But computer understands these statements or instructions in a different way. When the code is converted, the statements are converted into machine language instruction. For example, you are telling the machine to print hello world. So it's a statement. Therefore, it's a command. What makes it a command? Because of the print you bring there becomes an instruction that you are setting for the machine to carry out. So this command has a verb, which is the print, and you are telling the machine or the program to print these other words, which is hello world. A statement or instruction causes an action to be performed by the program. It translates directly into one or more executable computer instructions. So what you code in the program, it is an instruction or a statement to tell the program to do this and to do that for me. Most statements or instructions need a semicolon at the end, and some do not. Yeah, some statements comes with a semicolon trying to give a break in one or two statements that you code or instructions that you code for the program to understand or the machine to understand. But some statements also comes in such a way that it doesn't need the semicolon, okay, but it can still be classified as a statement or instructions. Now, let's note this. A statement can be a set of symbols, okay, numbers, or mnemonic used in a program. For example, int x, so integer x. So here you are using a special language, which is the int, to declare, okay, to declare this x as what? A variable. Therefore, this becomes a statement, which we also know that semicolons also comes with most of the statements we code. So semicolon is here to tell us that this is a simple statement or instructions that you are giving to the machine to understand. Let's take an example again. This example is a brief one, and I'll take you through. So we are saying instructions or statements. So we are giving a specific instruction to the machine or to the program to perform for you. Okay. So as you have declared this as a function, integer function, okay, then you are telling the machine to print the function, which is neso, okay, which comes with a semicolon. Then she'll return the answer to you. Okay. So this becomes a simple statement or an instruction that you are telling the computer to carry out. So a statement or instruction forms a complete unit of execution and is terminated with a semicolon. Yes, so this is a simple statement and it is also a complete statement to be executed. Now, let's look at some of the types of statements. The first one is expression statement. So what is expression statement? Any statement which is followed by a semicolon, okay, is termed as an expression statement. Okay, the input command stroke the output command, such as print function or scan function statements, are a typical example of expression statement. So this expression statement is known to go with, okay, semicolon. So any statement that you code which ends with semicolon, okay, is tend to be as what? An expression, because you are expressing that statement to carry out a specific task for you. Then two, declaration statement. Declaration statement. So what is a declaration statement? A declaration statement is used to introduce a variable or an identifier into the program or model. For example, int x. All right, this is a special word, which is the int, which stands for what? Integer. So we are using this special word to declare x into the program as what? An integer, a variable integer. Okay, so this is a declaration statement. All right, all right. Then our second is control flow statement. Control flow statement. So what is a control flow statement? A program's control flow is the order in which the program's code executes or help direct the order in which statements are performed with the use of sequences, selections, and loop. All right. So from the start of the algorithm to the exit or the close of the algorithm represents your control flow statement. All the actions you want to take effect in the program is what we termed as the control flow statement. So we use the sequence, the selection, and the loops, which combine to form a complete algorithm, is what we tend to be as what? The control flow statement of a program. Now we have assignment statements are used to assign a value to program variable. For example, x is equal to 2. So we have assigned x to 2 or 2 to x. But in other way, anywhere we see x, we should know that it is 2. So we have assigned 2 to x. Okay? Like the way we do in our elementary maths. Okay? So we use it to assign values to program variables. Okay? All right. Our fifth is iteration statement. So what are iteration statements? Iteration statements includes the ones which required running the same code again and again till a fixed number of times, or instruct the program to repeat a series of statements of specified number of times. Okay. Now, iteration, the simple name is also called loop. And we know that loop, you keep on what? Running a certain code for a number of times, okay, to get the correct answer or to get the correct output of what you are looking for. That particular statement is being coded or instructed to repeat itself for a number of times in the programming language. Okay, so in your control flow statement, you can have loop inside, which will be occurring now and then so that you can get what you want. So for iteration statement, there are statements actually embedded in the program just to ask you a certain question over and over and over again until the correct answer is being arrived at. Okay, so we have example as what? For loops, whilst loops, or do whilst loops. We'll cover that later on. Okay, so this is an iteration statement. So iteration statement also stands for what? Loop statement. Okay, all right. Now our sixth one is selection statement. What is selection statement? These statements help to make a decision using if clause. Okay, so we have the if clauses. If it is A, then so so and so. If it is not A, then so so and so. Okay. The seventh one is jump statements. What is jump statements? To transfer the flow of control unconditionally. Some jump statements are used. For example, return, go to, continue, break. So when we are doing the practical, I will intend showing you the various type of what the jump statements. Now the return, we have seen some of them already. Okay, so these are the jump statements. Yeah, colleagues, let's look at our next basic concept in programming: logic stroke arithmetic operators. So what are logical operators? A logical operator, also called a logical connective or a truth function, is a symbol or word used to connect two or more sentences. It always produces single results in the form of true or false, but at a time only one result is valid. There are three types of logical operators, and they are and, or, not. So this gives us the question: what are arithmetic operators? So arithmetic operators are the normal additions, subtractions, multiplications, and division symbols we actually use to do our various mathematical calculations in our classrooms. Their symbol goes as the plus sign, the multiplication sign, the minus sign, and the division sign. So what is so special about these two operators? So the arithmetic operators, they normally do the normal calculations that we normally use in our classroom. And in programming, they also represent a specific function in the programming. Now, when we look at the logical operators, they also perform a very important function, which give us a true or false functions. Okay, the result, a true or false result. And this true or false result actually makes us to know which of the statement or both statements or statement that has been given to you, which of them are true or not. Okay, all right. Now, on my table here, on my table, we are seeing the operators symbols here, the logical operators symbols here, their names here, and their examples and their result that they produces. Okay, so the first one is the logical end. The logical end. So this is the name. Anywhere you see it, it's called the logical end. Now let's look at the example. In this simple statement here, you are telling us that you assigned x to 5 or 5 to x. Anywhere you see x, it means that you have to substitute 5 into it, or into that position. All right. So we will say that 5 is greater than 1. Okay, so that is what we are saying here. X is equal to 5. So we have assigned 5 to x. Okay, all right. Now, in most of the operators, which is the logical operators, the logical end most often give us the result of what? False. Why so? It means that in this simple statement here, x is greater than 5. So this is true. But x is less than 4, or which is 5 is less than 4, which makes this to be what? False. Okay, so you cannot tell me that this and this are correct. Both of them. Okay, you cannot tell me that both of them are the same. They are not the same. Okay, so therefore it represents what? A false statement. All right, so this statement and this statement are not the same. So it represents a false statement. All right, now let's come to the logical or. So or here is also telling us that this statement, the first one, x is greater than 1, which is 5 is greater than 1, and 5 is less than 4. Here, this is true. Okay, the first statement here is true, and this is what? Is false. Okay, but in this statement, we are saying or, we are putting the condition or, so it means that yes, we are going to pick this one and we leave this one, which makes this statement true. Okay, now let's come to the logical not. Now the logical not is trying to let us know that yes, in all these statements above here, okay, in all these statements above here, we can see that there is only one that is making sense. Okay, it's only one that is making sense, which is the x greater than what? 1. So when we put the 5 here, it means that yes, the 5 is greater than 1, which makes this whole statement here true. Okay, we call it logical not. Okay, we call it logical not, but it is the truth. Okay, it means that we are taking from all these examples to mean that we have one that is really a logic one. Okay, all right. Okay, let's look at our next basic programming concept, which is expression. What are expressions, or what is an expression? An expression is a number, a variable, or a combination of numbers and variables and operation symbols. An equation is made up of two expressions connected by an equal sign. An example is this: the sum of 8 and 3 is equal to 11. So our expression is 8 plus 3 is equal to 11. So this is a simple expression here. So in our definition, we said expression is a number. So here we are looking at numbers. But we'll come and look at variables too, and you understand it very well, or the combination of both. All right. Okay. Now let's also bear in mind that an expression is a synthetic entity in a program language that may be evaluated to determine its value. Yes, in every expression, you have to determine its value. Otherwise, you are not doing anything called expression. Okay. Now, in programming also, an expression is a value. Yes. Or anything that executes and ends up being a value. Okay. It is necessary to understand that a value is unique. For example, constant, let, to, for, s, a, true, false, and world are values because each of them is unique in meaning or character. Now let's look at some example of expressions that we have in programming. Now, in the classroom scenario, we have this as an expression. We normally give this to our kids to work on. All right, where you assign a value to what? A letter. Okay, you you attached this to this and this, and so that when you give them the expression or the equation, they should just do what is called substitution to get the answers. All right, so this is the classroom type of what? Arithmetic expression. Now let's look at the programming expression. So in a programming expression, we have terms that we call all those things. So what actually we are looking for becomes what? Our variable. Okay, because in our definition we say that every expression we have to determine its value. Okay, so we are going to determine the value for z, okay, through these expressions. All right, so in these expressions here we have what we call the operands. Now the operands are the letters here that we are seeing. The operands are the letters and they can be manipulated, all right, by the operators, which is the addition, minus, and multiplication. All right. So we have these ones as the operators, the addition, minus, and multiplication as the operators. Then we have the operands as the alphabets. Okay, as the alphabet. I just want to explain it to the meaning as the alphabet. All right. Now, an operand is a term used in computing, programming, and mathematics to refer to a value or expression that is used to perform an operation. Okay, in other words, to make it simple, it is any object or data that is manipulated by an operator. Okay, so it means that all these operands here are being manipulated by the operators. Okay, all right. Now let's look at types of expression in programming. The first one, we have constant expression, integral expression, relational expression, logical expression, pointer expression, bitwise expression, and floating expression. Okay. Now, remember also that when you use the combination of the above given expressions, it is known as compound expression. Okay. It is known as what? Compound expression. Now, let's look at the meaning of each of the types of expressions that we are just seeing. Now, the first one is constant expression. So, constant expression, it consists of only constant values. Okay, a constant value definitely does not change. Okay, which give us the example a is equal to 2 multiplying 5 plus 10. So, this is a constant value and they will never change. Now, integral expressions. So when we say integral, it is inside. That means it is being covered. All right. So when we say integral, it produces integer outcomes. Okay. After implementing all the automatic and explicit type conversation. All right. So example, P is equal to x multiplying y, where x and y are integers variables. All right. Now, relational expression. It yields result of types bool, okay, which takes a value true or false. So it is also known as Boolean expression. Example, s greater is equal to what? 10. Whatever you get at the end is true or false. Okay, all right. Floating expression, as the word called floating, the thing is hanging in points. All right. So we said they are or they produce, okay, they produce point results after implementing all the automatic and explicit type conversions. Okay, so after a series of conventions, they produces results in points. You'll see that some of the answers will be floating, will be in points. Okay, we will get to understand when we are at the practical level, please. All right. Now, logical expression. Logical expression combine two or more relational expressions to produce results. Two or more relational expressions to produce results. So when you look at this example, we have relational and also logical expressions. So the logical ones are this, which comes with the sign, the and, then we have the or here. All right, definitely this thing did not come in, the not did not come in, but with these two we can say that it is what? Logical. All right, then these ones, the x greater than y, whilst the x is equal to 10 and the y is equal to 5, we can actually say that they are known as what? Relational, because we are equating what? The y to the x, then the x to 10. Sorry, we are equating the x and the y to 5 and the x to 10. Okay. Pointer expression, as the word implies, pointer, it produces address values. Okay, what actually you are looking for. So we normally use the abbreviation. Okay, we normally use the abbreviation, the PTR, as the pointer. Okay. Then the last one is what? The bitwise expression. Bitwise expression used to manipulate data at the bit level, okay, to shift it. So it can shift things in the right direction or it can shift things in the left direction. Okay, so this is the example. So we say X shift to what? 2 bits. Okay, it means shift 2 bits position to the right. All right, so we'll cover this in our practical sessions. Variables. What is a variable? A variable is a data item whose value can change during the program's execution. Okay, so variables, their values can change during the program's execution. So now, in a computer sense, the piece of information stores, okay, at this location is referred to as value of variables. Now, it may consist of, so variables, okay, variables may consist of letters A to Z, and also digits 0 to 9, and also underscore. Now, let's take an example and let's see. Now, in this example, we will see that there is a particular expression here, okay, and this particular statement that is here is trying to tell us that we have assigned, okay, we have assigned 20 to this integer age. So the first special word here, which is int, is the data type, which I always say that it is the integer. So the data type is the integer. Okay, then here the age is the variable what? Name. So the variable name we are using here is age. Okay, so which we equate this to what? 20, which is the value, sorry, which is the value. So this particular value is being stored in the system memory, which is already reserved down. Okay, so you putting up this statement here means that you are trying to tell us that we are going to work on the integer, the data type integer, and the variable that we are going to work on is what? Name, or sorry, age. Okay, so all right, now let's look at another one here. Okay, this one, we have the ID and the values. So in a program, this one, the first one here, which is age, is the variable name. So this one too is a variable name. Sign name is a variable name. Searching is also a variable name. Weight is also a variable name. Height is also a variable name. Okay, but each time you do everything, okay, each time you are searching for someone's age, it might change per the definition here, which states that the values can change during the execution of the program. So you might be looking for Kofi Mensah. The age will always be here, which is the integer, the data type, okay, age. So the age always will be here, but the value of the ages will be changing. Then the sign name will be here, but the sign names will be changing here because you are searching for different types of what? Names, okay, sign names. So the one that you are looking for will pop up, but it will not pop up like the same one you've already searched on. Okay, so the ID session represents the variables that you are going to search on, and when you are searching on the variables, then the values of those variables might be changing due to your search program or due to the search that you are doing or what you are looking for. All right. Okay, so variable in total, as we said, is a data item whose value can change during a program's execution. Now let's look at some of the rules, okay, when naming conversions of a variable. All right. The first rule is that you cannot use punctuation marks and blank spaces in a variable name. No. The second rule says that the first character of a variable must be a character or underscore. The first character of a variable must be a character or an underscore. Okay. A variable can consist of numbers, characters, and or underscore. You cannot use keywords as variable names. A variable name must not start with a number. Then the last one is a variable can be any length. So now on my table represents the various type of programs we have and the example of how variable is being represented in those programs. So the C++, we have double value, which is 3. The C hashtag, I always call it C hashtag. So the double variable is 3. The Java double variable is 3. JavaScript. So if you look at the table, they have all, they are representative in the various programs. Okay, colleagues, let's look at our last basic concept in programming in this unit. Now, constants. What are constants? Unlike variables, constants refers to fixed values that the program may not alter during its execution. These fixed values are also called literals. So unlike variables, constants, they are fixed. Okay, they are fixed value and they are not to be changed or they cannot be changed. Okay, so they can also be called literals. Okay, now the constants are treated just like regular variables, except that their values cannot be modified or changed after their definition. So, as I already said, you can't change these particular variables. If you have keyed in your code, that those particular values cannot be modified again. All right, they are constant to the end, such as let's say pi. Okay, pi is a constant value. All right, that will be occurring in most of the things that you want to execute. Okay, if only you have pi in your program to execute a certain calculation, it means that pi will be a constant figure that will be applicable in the program always. Okay, it will not change. All right. Okay, now constants can be any of the basic data types like one, integer constants. Okay, integer constants. Now integer constants come in a form of decimal integer constants. So we have decimals which have 1, 3, 7, and etc. They are also there. Then we have octa integer constants. They come in 3 figures and 4 figures. Okay, all right. So we can also see constants in a floating data type. Okay, in a floating data type, which is an example of negative 2.0, 2.15, and etc. So that is a floating constant which give us what decimal points, okay, or give us points in their values. Okay, then we can also get some constants in a character form. Okay, so in the character form we can have A, M, F, A in caps. They too, they are also there, right? Then some constants also come in a string literal form, which is A, B, C, D, hi, hello world, I love Java program. Those kind of things are also string but literal constant values. Okay, so let's note this that most programming languages use all caps to define named constants. Okay, yeah. So when we begin practicals, you will get to know how all these are being used in programming or in algorithm. Now let's look at some of the uses of constants in programming. We have two major types of uses. Okay, the first one is literal constants. Literal constants. Literal constants. So literal constants or a literal constants let you define and refer to data directly in machine instruction operands. Okay, in machine instruction operands. So it means that in this particular constant, okay, you can go in and locate any variable that you want to change or you want to input. Okay, whether the beginning, the middle, or the end. So this literal constant means that yes, even though it is constant, there are some things that maybe you might wish to add to those things to make it full. Okay, but it means that the core value of it will not disappear, but it's just that you need to add something to it to make it meaningful. Okay, that is the constant. So examples include the constant use of initializing a variable. Okay, so to start or to prefix a variable. All right, you initialize a variable or bringing a variable into the program. All right, and also constant use in lines of codes. Okay, there are some constants that you use in the line of your coding. All right, so other examples of these literal constants are the 21, 12.34, the a caps, hello world, false, null, etc. Okay, so these are examples of literal constants. All right, then note most programming languages use all caps to define named constants, as I said earlier on. Okay. The second uses of constants is defined constant. So you can define a constant. Okay, so these constants are defined. It means that from initial, from the start of the program, you have defined it. And yes, it will not change as usual. So what are the defined constants? So the defined constants, they are constants that uses defined directives, okay, to execute a program, such as using the one hashtag define preprocessor, okay, which will be used frequently. Examples are this. So hashtag define pi. So the pi comes with a name and what? The figures. All right. Then hashtag define new line. Okay. So new line comes with the apostrophes, then over, then n. All right. So in this form of constants, it means that you are defining a particular constant that will work throughout the program, which will never change. Programmed to be there, and no additional changes will be done to it. No addition, no subtraction. Unlike literal, you can go in, then you do some adjustment, but it still remain constant. Okay, but in defined constant, you cannot do any addition, any subtraction at all. Then two, in a defined constant, you can also define some constants with what? Constant keywords. Okay, you can use constant prefix to declare constants type with a specific type as follows. So constants type variables. So this type here is a keyword. Okay, this type here is a keyword, but you are using the constants, okay, to say that this type will always be constant in the program as the variable, okay, will be equated to what? The value. Okay, then when we come to the second one, to the int here, which represents integer, is also a keyword. Okay, so you are saying that let this keyword, let constants, so constant integer be constant inside. All right, so you are saying that they should be constant variable. All right, which should be equal to what? Any value at all you are doing the calculations, or you are writing a program of on. Okay, so these are the two ways we can use constants in our program. When you look on my table here, we have the various languages and we have the way they define constants in their various programs. Okay, so in the C++, you still have to use the this thing hashtag define. Then you bring what? Pi inside, or you can say constant double, then pi, then you bring the value attached to it. Okay, so when you go to C hashtag, that one too is constant double, then pi. It's just like you just write the code, all right, like the way it is, you just write it. Okay, you just write it this way. It means that you are coding in the variable. So you just have to know the program which you are using to write your code. Then you know what to apply as their definitions, the constant definitions in that particular program. With that being said, I think we are done with our basic concepts in programming. So thank you very much for watching this program. And please get down there and hit on the subscribe button for me. Please get down there and hit the subscribe button for me so that I will also update you with more and more tutorials from the classroom. Thank you.